well, that's a challenge in itself. The other dry fibre option, again, is a tape option, which would be similar to a pre-preg tape. So quite versatile, but definitely much lower deposition rates. And these are the options that are being explored. And Wing of Tomorrow is all about exploring options, understanding the benefits, understanding the trade-offs, and getting the learning so that when we come to launch the next product, we can make the right choices. So just a few pictures and videos in terms of deposition today in Airbus. So on A220, we are using large non-crimp fibre dry blankets, but the process of deposition is manual with very skilled operators and therefore relatively low rates of deposition. On A400M, the selection of material was the ATL. So this is wider single tapes, which can have different shapes cut into both ends, but apart from that, then it's harder to optimize. On A350, we have AFP, where we have multiple toes on the machines, laying several strips of tape together. These machines are able to lay up over contours, which is a benefit, and able to very much be optimized for the shape. But the deposition rate, therefore, is obviously less than it would be with the large blankets that you might have on dry fibre. So all of these different technologies have benefits, have drawbacks, and of course, over history, we've learned a lot and we've evolved. And Wing of Tomorrow is now the next step in that evolution. So, having talked about the deposition challenge, there are many other steps in the process that are very, very labour intensive and probably present an even more difficult challenge for automation, and bagging would be one of those. So today, if you use classic vacuum bags over the component once it's on the tooling, it's a very heavily manual process. It uses, we know, a lot of consumables, which potentially creates a lot of plastic waste that can't be readily reused or recycled. There's lots of studies and lots of examples of where reusable bags or semi-rigid bags can be used as an alternative, but certainly this is an area that is very labour intensive and does create a lot of waste today if you think about classic bagging technology. Infusion and cure, so the state of the art there, certainly for A350, would be autoclave, classic pre-preg in autoclave cure. We also on A350 do have some components that are vacuum infusion, so dry fibre vacuum infusion, including the rear pressure bulkhead, and even on A400M, the cargo door. So those are out of autoclave, but the wing covers, the main wing components today on A350 are in autoclave. And of course, that brings its costs and its challenges in terms of energy and water consumption. In terms of efficiency, because of the loss of energy when you're heating and cooling these very large tools, which also then drives a very long cycle time. And of course, just the sheer equipment costs of needing to buy the autoclaves in order to have enough capacity for your production. So there have been some material developments in terms of speeding up the cure and different material systems, but those are fairly incremental improvements, really. What we're looking at on Wing of Tomorrow is a step change compared with this in autoclave historical baseline activity. NDT is another area. Today you'll be pleased to hear, inspect those large A350 covers like the picture with one guy doing that by hand. We do have automated large ultrasonic C-scan systems for A350 covers, but still they run at a certain rate. The covers need 100% inspection, and the analysis of the data is a huge challenge. So getting the data by scanning the component is one thing. Analysing it is another whole challenge in itself. And in some areas where we've got integrated components, so stringers integrated into maybe a curved skin, for example, there is the need for manual analysis with inspector input required to actually understand what the NBT data is telling us. There are many other challenges, like the fact that some materials are more difficult to inspect. And of course, the further we go down the road of more integrated composite structures, as I've explained on Wing of Tomorrow, the more complex the inspection becomes, and potentially the longer it will take and the more difficult it is to automate. So this is another big challenge for us. And then I'm just going to mention sustainability and end-of-life recycling. It's obviously not the main focus of the presentation, but it's something that's in our mind at every step of the way, because this is another thing that always has to be traded off when we're making decisions about the design and the industrial system for our wings. So the trade in terms of how much consumables you use versus investing in more expensive tooling, for example. Sustainability and waste is a key part of that trade. Buy to fly ratios are important. So by that I mean optimizing the amount of composite you deposit in the first place in order to reduce the amount of waste of uncured composites that you produce, in order to reduce the offcuts, looking at how do we optimize nesting in order to get the best buy to fly ratio. And then with components that require trimming post cure, so where the components aren't made to a net edge and have to have trimming after cure, that's then another potential source of waste. So this is always in our minds when we're thinking about the different trade-offs between the materials we select, the design of the components, and how we decide to manufacture them and to put those components together. Okay, so I've sort of given you a bit of an introduction to Wing of Tomorrow and a little bit of history on Airbus composites, particularly focused on the wing. And I've talked about some of the process steps and some of the challenges that those present for us, and hopefully you've understood some of those key messages. So I'm now going to just talk a bit about the automation developments that we are working on. I'm going to be focused here mainly on the work we're doing with the National Composites Centre here in Bristol, who, as I've said before, are a key partner on the programme. So we're working with the National Composites Centre on making one of the most complex component on the Wing of Tomorrow programme. They're the partner on the top cover that I showed you on the picture before. And really have been working with us on the programme right from the beginning and in fact before Wing of Tomorrow really was launched. So it's a very important partnership for us. The team work together as one team. The Airbus and the National Composites engineers work together as one team in a very integrated way, and we're on the journey together, I would say. So one of the most important investments that underpins the Wing of Tomorrow programme is the pilot line at the NCC, which you see a photo of here. So this is all about composites automation for us, and it's all about understanding what is the potential to reduce costs, cycle time, and also to improve quality. I haven't really mentioned quality before, but of course, automation does lend itself to repeatability and therefore hopefully lends itself to improved quality and also the possibility to assure the process rather than 100% inspecting the output. And all of those things we're exploring in partnership with the National Composites Centre. So the pilot line has a 26-metre track. So I mentioned before that the Wing of Tomorrow covers a 17 metres long. There are 2 gantries with 7 metres with robots on, and this is capable of ply cutting, pick and place, PFP deposition, and also rolling and unrolling the dry fibre blankets that I mentioned before. So it gives us a capability to explore all of those automation opportunities that I've talked about. So just some very, very simple process videos talking about the process of making the cover. Obviously the robots measure, cut, lift and place those pieces of carbon fibre, either the DFP tape or the NCF blankets, with very, very high accuracy, which is very important to us. The system can lay up to 5 metre wide blankets, up to 20 metres long in one precise movement, and then it's integrated with a full-size oven as well. In addition, we use the ultrasonic knife capability to cut the plies to shape as well before we cure. So it's a fully integrated system that we're using for Wing of Tomorrow. In addition, we have the fibre form capability, which is the pick and place, which is 270 suction cups. Here you can see it described on the slide, to pick up the smaller pieces of composite and accurately place them in the right place onto the wing covers or spars or whatever the component is that's being made. And this is obviously very helpful because wings are not flat. They wouldn't give us a very good aerodynamic performance if they were. And so therefore being able to place over a formed surface on a formed tool is very important to us. The fibre roll capability is very important to us from a deposition rate point of view. So this is about exploring the art of the possible in terms of being able to lay down blankets very, very quickly at high volume and really understand what deposition rate a system like this might be capable of when it's scaled up in the future. So all of these capabilities are very important to us on Wing of Tomorrow and are an intrinsic part of the programme, as I've said. And we are actively making our full-size components today at the National Composites Centre using these technologies. And we are learning every day with the National Composites Centre team in terms of the potential. And we're learning what works and what doesn't work. And actually that's also very important because we all know in the world of technology that sometimes learning what doesn't work is almost as important as learning what does work. So it's a bit of a roller coaster, but it's a very interesting ride that we're on together. I talked before about autoclaves and about cure. So what we're exploring with the National Composites Centre as one of our technology options that we're working on with Wing of Tomorrow, because I mentioned before we are looking at more than one technology option. We are looking at other pre-preg alternatives as well, but with the National Composites Centre we're looking at the dry fibre out of autoclave resin infusion. So once the fibres are assembled dry using the material into the mould, we're then infusing using the oven that you see in the picture here, and avoiding the need for an autoclave. So this then becomes a different cost trade for us, because this is about investment in autoclaves compared with ovens or even heated tools, for example. This is another good area that we're exploring that has the potential for reducing investment in future. And just one other picture here, which is actually not the National Composites Centre, but this is GKN, who are a key partner working with us on the programme, who are also using RTM technology as opposed to resin infusion technology. And this is a picture of their 4-metre mid-scale demonstrator tool for wing spars, which they are working on with us at their Global Technology Centre, also here in Bristol. So this is, again, a very good enabler for us to being able to make very accurate, high quality, net shape parts for our future programme. So this is another different application of the dry fibre technology that we're working hard on with our partners GKN. Moving on to NDT, so again, this is part of the overall capability at the National Composites Centre, the NDT inspection technology. This is what's known as the civic cell, where we will inspect the covers that we make at the National Composites Centre. So this is a state-of-the-art ultrasonic cell, which uses 2 robots, as you can see in the video, to scan the component. Now you can imagine if you've got these very large wing covers, the ability to scan quickly and accurately and then process the data is a real enabler to rate. So this is another important part of the overall capability that we're exploring for the future. In addition, we're also looking at different NDT diagnostic techniques and also intelligent visual inspection, working with the Airbus Testia organisation as well. So there's various different aspects of the NDT activity that are key to us going forward. And then just to come back to the sustainability question. So I said before that sustainability becomes an important part of any trade that we're making. And so the sorts of things we're looking for there are, first of all, net shape parts. So by making the parts to net shape, we can minimise waste through avoiding cut-offs. We're also looking at optimising bite-to-fly ratios in terms of the input to the component. We're trying to look at how we can recycle the materials, not only the composite materials themselves, but also the auxiliary materials. So again, another stream of activity that we're working on. And then, of course, we know there are more radical solutions like biosourced materials, which are also the subject of our R&T within Airbus, working with other partners. And the key thing to keep in mind is we need to be designing for the whole of the life cycle, including the end of life of the product. And that's something that's becoming a stronger and stronger theme of our work as we move forward, as you would imagine. Okay, so I'm just going to come to the conclusion now. I've tried to give you a view of Wing of Tomorrow and the processes and the challenges that we're working on and some of the developments that we're doing within the programme. It's, as I mentioned before, a very, very complex, very far-reaching programme. And therefore, I'm giving you a flavour focused on the work with the National Composites Centre mainly, but there are many, many other parallel activities that continue as well. So I think in terms of conclusion, I would say that, firstly, hopefully you've seen the ability to make our composite wings cost effectively is going to be the foundation for any Airbus product that we launch in the future. A Wing of Tomorrow is part of that journey towards Airbus meeting those targets, not the only part, but a very big contributor. And in order to make Wing of Tomorrow a success, partnerships like that with the National Composites Centre are key to making the overall programme a success. This is only part of the story, as I said, and there'll be much more work to increase automation throughout the process, not just the deposition and the NDT that I've talked about today, but all of the steps of the process in order to meet our rate targets. And we must always keep in mind the route to sustainability, because that is always going to be a focus for our future. So that is the end of the presentation. I think I'm just about, I'm probably about 5 minutes under time. So hopefully that gives enough time for some questions, which I'm happy to take.